Advanced Math, Lesson 71, the ellipse. So, really quick, we're going to start off with locus definition of an ellipse. So, the locus definition is the circular shape that is made when you find all the points whose distances add up to the same distance let me find a way to say this. Okay, so let's say we put one stake in the ground here, we put one stake in the ground here, and then we put a big long rope, a rope that was longer than the distance between the 2 points, and we connected them to each stake. If we were to take a piece of chalk and then use the rope to draw around, it would make an ellipse. So it's really cool. You can try that in next time you're in a sandbox, because I know all you high schoolers love playing in sandboxes. At the beach. Next time you're at the beach, bring 2 stakes and a cord and do math. It'll be great. All your friends will love you. Anyways, this is the locus definition of an ellipse. We have 2 fixed points inside of the ellipse, and every single point on the ellipse is equal to the distance of both points to that point on the ellipse combined. So, at all points, no matter what point we're at on the circle, D1 and D2 will always add up to the same number, as they will here. In this case, D1 and D2 will add up to the same number. You can go all the way out here on the outside. D1 and D2 would still add up to the same number. So that's the main thing with an ellipse. Now, a little bit of orientation here. Ellipses have a major axis and a minor axis, right? The major axis being the longer distance, the minor axis being the shorter distance. And then we have standard form of an ellipse, which I'm just going to write over here. So standard form of an ellipse goes like this. We usually have x squared over a squared plus y squared over b squared, and it will always be equal to the number 1. Always. Always, always, always. Now, the way this works is in this ellipse, if we were, let's do 3, and then we'll do 4, right? So let's say we have the following ellipse. Okay, so we've got this ellipse. It's beautiful. The thing that we're looking at here, the a squared, is in proportion to this distance right here. That is a. Now, the other letter we've got here, the b squared, is in relation to this distance right here, which is b. Now, we can see from our graph that these distances are pretty simple. The b is going to be equal to 3. The a is equal to 4. So the standard form of the equation of this ellipse that I drew right here would be x squared over 4 squared plus y squared over 3 squared equals 1. I drew on my ellipse. That would be the equation of the ellipse. And then, again, wait, hold on 1 second. Oh, yeah, we would simplify this. So 4 squared we would just write as 16. 3 squared we would just write as 9. And that's how you would view the ellipse. So let's do some practice here. Now that we know all this cool, super fun information, you guys are prepared to draw ellipses in the beach. Beach sand, that is. Let's graph the following ellipse. We have x squared over 25 plus y squared over 9 equals 1. So, that's a 9. It's not an A. I know some of you are calling it an A. It's a 9. All right. So, really simple to graph. This one's going to be at origin because it's not shifted, and we haven't learned how to shift them yet because we just learned about ellipses today. The major axis we can already tell is going to be the x-axis. It's going to have the bigger number. Square root of 25 is 5. So I go over 1, 2, 3, 4, 5, and I put 1 point. Then I go negative 5. I put another point, right? Then I'm going to go to the y. Square root of 9 is 3. So I go up 3. I go down 3. Those are the 4 points of my ellipse, and then I draw it. Ta-da! That's how you draw an ellipse. Super easy to graph. That's not really the hard part of this lesson. So graphing an ellipse is really easy once you know how to read the equation. Now let's talk about writing the equation of an ellipse in standard form. So let's say we've got, actually I guess I should go to paper for this. All right, so let's say we've got the equation of an ellipse is written like this. 5x squared plus 2y squared equals 15, right? They say write the equation in standard form and then graph this ellipse. Okay, so I guess I'll grab the thing when I have to graph. Now, this is not in standard form. First thing, it's not equal to 1, and then these are not fractions. X and y shouldn't have the coefficients. So how do I write this in standard form? I divide by this number right here. I'm going to divide by 15. I'm going to divide that by 15. I'm going to divide that by 15. So once I do all that division, let's see here. This cancels to 1, and that becomes 3. So I've got x squared over 3. This is 1, and then 15 divided by 2 is 7.5. Yes, I'm going to use a decimal, and you will too, right? So this will be y squared, and that will be 7.5. So if you're writing the equation of ellipse and you want it in standard form, if you have to use a decimal in the denominator of your fraction, you can, because we want this to be equal to 1, and we don't want x and y to have coefficients. We just want them to have denominators. So it is now in standard form, and that's really how easy it is. You just, you set you divide by, you make this 1. Okay, let's go into graphing. There we go. So my x squared is over 3. So that means the distance here is actually going to be square root of 3. If you remember, square root of 3 is a little bit bigger than 1, but smaller than 2. So I'm going to have an x that goes here and here. Okay. And then 7.5. What's the square root of 7.5? Oh, that's really tough unless you have a graphing calculator. Okay. Second square root, 7.5 equals 2.738 or 2.74, or just 2.7. So for the y-axis, I'll go almost to 3. And then, ta-da! I drew my ellipse. Yay! This is x squared over 3 plus y squared over 7.5 equals 1. Any questions about that? Cool, I hope not. Ellipses are super easy, lots of fun because they're like easy points on a test. If you guys have any, if you guys have any questions, let me know on Moodle. I'll see you in class.